This is a session where we discuss ROS2 as well as and path planning simulation. Okay, in ROS2. This is the agenda, but I just want to know how. Hey, parallel, Sumara. So, how many of you guys actually worked with Raspberry Pi? Raspberry Pi? No. Raspberry, no. Okay, how many of you guys worked with Arduino? Arduino, yes. Okay. So why we use Arduino, by the way? Can anyone answer? What is the use of Arduino? Okay. So okay, the basic controlling we are doing in Arduino. Okay. So there are pins, right? Digital pins and analog pins. You can actually use up to a certain number of sensors, right? But when it comes to building an complete robotic system, we need more sensors. I mean, we need more pins basically. So in that case, we are using more input and output things. In this case, like the communication between the each module here in this context, what I mean module is, let's say let me take my own project itself. My project is self-driving autonomous system using a two-wheeler scooter. Okay. So what is that is the lidar. Have you guys heard about lidar? So what it will do is it will give you a mapping around your system, right? So I'm using a 2D lidar, and this lidar will help me to recognize what is around my system, and using this as well as my camera for object detection and path planning, lane detection basically. So using these stuffs, we can actually make it run autonomous on a particular lane, or with more ML models we can make it overtake some vehicles and stuff. So this is just a simple example, but when you are planning to build an product, autonomous product like Tesla, they are almost using more than 50 or 100 sensors in their car. In that case, we can't use simple Arduino or Raspberry Pi. So what we will do is we will be using basically a computer itself. So the main problem here is there are multiple domains in a particular single system itself. Like one domain should take care of the camera modules, one domain should take care of the lidar things, and there are multiple domains like this. We can call it as modules. Okay. um, so in order to make the system run perfectly, or at least in a good way, we have to make sure the communication between the all the modules should be correct. So that's where ROS comes. So ROS full form is Robot Operating System. It will give us the pre-built libraries where we can use it to communicate between the sensors. It is very easy actually. So what is special about ROS? ROS is actually an open source. Have you guys heard about open source? So open source is nothing but the code of the particular program will be available to all, and you can use it, modify it, and you can actually build your own stuff using that. And as you can see, what I told is that they provide more tools and libraries for the better communications between the modules and stuff. And okay, I will go in that way itself. And as I said, it names actually speaks for it. Robot operating system, it is used in most of the robotics stuff. And okay, now we are going to see about Linux. We can't actually use robot operating system in Windows. I mean, we can technically use it, but it is not optimized to be used in Windows. So in that case, what we are actually going to use is Linux system. Have you guys heard about Linux? So Linux has many distributions. Okay, Linux is an open source basically. So any company like let us say any company can take a Linux source code and modify and use it as their own OS. For example, in Android, no, right? Android is an open source. but when you see Oppo, Realme, and stuff, they have their own Oxygen. OnePlus and all has Oxygen OS, I guess. So it is built on the Android system. So basically, they are using open source stuff. So like that in Linux, there are actually distros. They call it distributions. We can also say distros: Ubuntu, Fedora, and Debian. And we are going to use Ubuntu here today. And why Ubuntu? Basically, there are two versions in ROS: ROS1 and ROS2. ROS1 is the starting version of the thing, and ROS2 is the modern version of the thing. And ROS2 actually supports better in Ubuntu, so we are going to use Ubuntu only. And yeah, it is free, secure, and stable. You could. Okay. Ways to use ROS. I mean Linux. So basically, all we know about operating system is we know Windows. There will be how to say, there will be GUI, graphical user interface. You can click and stuff. Most of us will not work with terminals, but at the early stages or the programmers basically work in terminals. Okay, so working in terminals give you it takes more time to understand it, but it is the most easiest way to use it instead of GUI. So these are the ways to use it. Command line interface and graphical user interface is the thing Ubuntu desktop, and then SSH remote access is nothing but you can actually use your system using an IP address remotely. That's a tool. And dual boot or virtual machine. In this session we are going to use virtual machine, not dual boot. So have you guys heard about dual boot? Okay, so yeah, a dual boot is nothing but we have Windows in our systems, and we can actually install another OS alongside Windows. And while starting the system, you can actually press F10 or F2 to get into that boot menu, and then we can select which OS we have to go. Or else you can go to BIOS settings, and you can set that you can change the default OS things. So if you don't press anything, it will defaultly go to Windows or Ubuntu. It depends on our settings. And Docker is, have you guys heard about Docker? Okay, I think it's kind of complicated, not complicated, but Docker is like, let's say you guys are working in a company and you are working under one project. uh, so of course you are not going to work in one system, particular system. You guys have will have a unique system for respectively, right? In that case, let's say a person A or person X actually runs an project code in his system, and after him, next day a person Y should work on his system or his own system. He have to run the program in his Y system, right? So but the program will not run. Why? Because there are libraries, dependencies which is installed in the X system will not be or might be missing in the Y system. In order to reduce this conflicts, we can use Docker containers. So what we can do is, instead of just giving a project file, we can actually give an OS image itself. So we can actually publish the OS image in Docker. They have an online server kind of database kind of thing. So we can deploy the OS there, and the Y person can install. They can pull the image to their system and run the program. It will run successfully. That's the thing. It's fine. It's fine. Parleya. TV pizza. ಇಲ್ಲ ಇದು ಆಫ್ ಆಗಿದೆ ನನಗೆ. ಆಫ್ ಆಯ್ತು. Okay, fine. Okay, I'm not actually going to use PPT and then leave the session. Actually, I'm going to show you guys how to create an virtual machine, and then how to actually install ROS and stuff, and then we will go to the A star algorithm. Have you guys heard about A star algorithm? Okay, have you worked on it? Okay, so I will go to that in a minute. Hitesh. Okay. Okay, these are the terminal commands. Okay, you can use in Linux, and then basically with this command you can do stuffs like, can you see the basic commands? ls is nothing but if you have a folder called downloads, okay, or documents in our windows, you open the terminal and go to the directory, like let us say, not even go to the directory, you want to see what are all the folders which are inside the particular folder. You are going to give ls and enter. It will give the what are the folders inside it, names of the folders inside it. Don't worry, I will actually explain it by doing it. I'm just going through it for now. And cd is nothing but change directory. You can actually change to a particular folder in the command line actually. And then make their pw is okay, I will explain it in practically itself afterwards. It's, and as I said, ROS2 is a latest version of ROS. And as we saw in Linux, there are different types of ROS actually. So here we are going to use Humble, ROS2 Humble. So there are more versions of ROS2 like Foxy, and then I Noantic, I guess it's ROS1 variant. So why we are you going to use Humble is it is a long-term support. Okay. In if you guys know, have you guys worked with Python? Okay. In that things and all, we can actually see something called LTS version. So LTS version is nothing but they will give the support to that particular program for a long time, and there will be a lot of versions of that particular program which will be short term. So most of the time we are not going to use short term because since it will provide long term support, right? That's why. And then before going to ROS2, ROS2 is an ROS2 is built on something. Okay, so this is ROS2 means it actually has a middleware. The middleware is called data distribution service, distributive service. So that is called DDDS based communication. What it will do is basically why we use ROS is to make a better communication between two Python nodes or multiple Python nodes. In order to achieve that, we use DDS. For example, where we use DDS is, can you see the UU over there? In that system we are having a Linux. Okay, it is actually running on ROS, but we can't say technically it is running on ROS. It is actually using DDS. So what it will do is, first I will say three types of communications in ROS. Okay. Okay, there are three types of communications. One is server and client. Have you guys worked with server and clients in web development? No. Okay, no idea. So in that case, okay, so let us take an restaurant then. So there you will be sitting on your table, and the server will actually come to your place and ask what you are going to order, and he will take your request, go to the thing, go to the place, and they will tell the order and they will bring back the thing, right? So the food, like that. Server and client is like, for this I have to explain backend also. So we have database. Okay, database is the place where we store all the data. Let us say, let us take an example of YouTube itself. We are clicking on many videos, right? Let us say you are going to click on some video, and once you click, what will happen is an API request will be sent to the server. So server is like, I will, okay, so here let's say this is the browser window of like your tab of, okay, your tab, and you click a video, and an API is sent to the server. And what will this server do is, the server will process the API and then get the data out of it. Like it, the server will talk with the database and say he needs this kind of video. The video has an ID, so the server will check the ID and it will take the a video or some data, and it will give back to the system, like to our system. So this is a basic thing. It's not you know it's not only about web development, it's a front end and back end stuff. So like this, this is how server and client work. In ROS, what will happen is we can actually say that one Python file is a server and one Python file is a node. Python file is a client. Okay, so you can actually get a basics of it. Like a client Python file will request something to the server, and server will give the reply for it or the data for it. So that's how server and client works. You can actually see this you have to make a request to get a data. That's how server and client works. And there is a second type which is like publisher and subscription type. So you guys will be familiar with radios, right? So what radios will do, there will be a station, and that station will publish their content on the signals frequencies, and we will use the frequencies to receive the signals, and we will listen to it, right? Like that. What the subscription and the publisher will do is, we can set an Python file as a publisher, and the Python file will publish no matter what the data. So the subscribing Python node can be subscribed to this publisher, and the communication is not like an you have to ask it or retrieve it. The publisher will publish no matter what. It will be publishing. You will be only receiving. You are not going to talk with it. So that's the types of communication between the nodes which is available in ROS. And do you guys have any doubt now? Because I am actually running a bit. I have 1 hour of time and I can't actually show you everything. But if you guys have any things to clarify, I mean, I can clarify it.
The installation.
Installation cost, right? Yeah, I'll tell you. Okay. Yes, actually I told three types of communication, right? The one type, another type is like it is very complicated. I couldn't able to get an analogy of it, but it will look like as if we combine the both the types. Okay, so we will see in few months, because we are actually planning to take an ROS workshop again in this lab, specifically for ROS. It will be maybe 2 days or something in upcoming months we are planning. So in that time actually we can give an solid examples, and we can also make you guys install ROS and stuff. It will be very interesting, and since it is a time taking process, I can't able to make you guys work on it right now. There will be more error, and that's a issue why we haven't done it in hands-on. Yeah. 45 kilometers. Okay. நான் இங்க நின்னா இவங்களுக்கு தெரியாதுல்ல எப்படி நின்னா. Okay, so it will, okay, this is VMware workstation. You can use Oracle also. This is a virtual machine supporting software basically. So you guys know what is virtual machine? Any idea about it? Virtual machine. Okay, so basically, let us say you actually want to learn ROS, but you have only one system. You are not going to buy another system or anything. So what can you do is, there are two ways. One is dual booting. You can actually make a pen drive, a bootable pen drive, and then you can actually do what I said in dual boot, right? You can actually do it. Other simple step is using a software like VMware or Oracle virtual machine software. So in that, what we can do is, like, all the different softwares will have a similar UI to this, so that you guys don't have to worry about it. Let us say you have to create a new virtual machine. Virtual machine is nothing but, this is a one machine, and you can actually build an subsystem in this machine itself. So I can show you right now. So we are going to go with typical recommended method, so we are not going to go for advanced thing. And in this place we can actually select our OS file. Okay, so since we are going to use Ubuntu, we can actually we have to download it from net. In Ubuntu website we can actually download various version of them. Here I'm going to select Ubuntu 22.04. So this Ubuntu 22.04, what is the reason between the specific version is ROS2 Humble will work properly on this version. So as I said, ROS has an different types of like different levels of versions, right? This version will particularly support Ubuntu 22.04. So if I click next, and then it will ask me what is your system's name and all. Let me say ROS or something, and you have to give password. And it will say what can we can actually customize the name of this machine. I am going to stay with Ubuntu 64-bit, and then we can actually see here there's a single file and multiple file, right? So in the virtual machine we are going to save some files. Without storage we can't actually say something and machine, right? So in this place we can say that use a single file in my own system instead of multiple files. So what it is like, you are using you are downloading some files, and we expect it to be downloaded in a single file, not in multiple files scattered around it, right? So we are going to select single file, and we can mention how much space we can actually give it to the respective machine. So right now, since I am doing for demo, I am just giving 20. And if you want to learn ROS, 50 or 40 is recommended. And GB. Okay, and then if you click finish, it will be working, and you can actually open it. I'm not going to actually create one because I already have one here. This is my ROS virtual machine I am actually running. So here you can see I have given 9.9 GB of RAM. Since my system is 16 GB RAM, I gave it 10 GB RAM itself. You can give it as per your system specification. And then I gave 40 GB as a storage, and then I gave 8 processing units. Mine has 16, so I think 8 will be sufficient. So like that, once you finished your virtual machine but you want to change some settings, means you can click here and actually change the variable, I mean parameters or values of it. So right now I will turn on my system. So this you can actually see the Ubuntu screen. It is booting now, and yes. Mm. By the way, when you do the same what I am doing now, you will not get a screen like this because I customize my Ubuntu like that. Your Ubuntu will look different actually. So mm, first we will see how to install ROS first. One second. So since it is open source, it will be well documented. You can say ROS2 documentation, and it will appear on the first. And I think you have to give specifically Humble, right? So if I give Humble, it will give the documentation for Humble version, and then If you click installation here, it will direct you to, okay, yes. So here you can see there are three OS it will support. It will support Ubuntu Linux, and then Red Hat, that OS, and then Windows 10. Okay, I mentioned that we can't use it Windows, but it is showing Windows 10, right? Actually, we can use it, but it is not recommended. So when you want, if you want to do install it in Ubuntu, you have to click here and follow the steps actually. So here are the setup steps. So if you copy paste it on your Linux system like Ubuntu system, these following commands, it will run properly. And there are chances of getting more errors, but don't worry, there are many forums, and you can use ChatGPT to rectify the errors. Mm, mm, yeah, then the phone. Okay, snap. Okay, so in order to use ROS, what you have to do is first, first you have to install ROS, and I showed you the documentation, right? You can actually go through the documentation. It's not that big. You can actually copy paste the comments in it, and then once it is set it up, what you can do is you can create an you can create your workspace. So what is workspace? Workspace is nothing but let us say you are going to do a project, and that project, as I said, there are many multiple modules in it. So in order to put it into a single folder, we call it as a workspace. So let me create a workspace here. So how you guys will create an folder in Windows actually? Okay, so you will right click, and then there will be new, and then you will go to the new folder, right? You will use that. But when it comes to you can actually do that, but since we are kind of programmers, right? So we have to do it in terminal. For that, we have to give this command mkdir. Okay, so this is make directory. We can say, so if I say the name of my workshop, it will create me an what do you say? It will create me a folder itself. So if you want to check whether this folder is there or not, you can do two things. You can actually give ls. Ls is nothing but what are all the subfolders inside this directory. Okay, so inside this directory there are these many folders right now. So there you can actually find the makedir, I mean that workshop. One second. இங்க இருக்கு. சித்தேஷ் ஒர்க் பார்த்த எனக்கு தான் தெரியல, ஒரே நிமிஷம். Okay, so here you can see the workshop folder created. So if you okay, so workshop workspace is created, but we haven't actually did much, so right. So what we have to do is there are four folders which should be inside an workspace. Okay, one is log, which log is nothing but when you are running your ROS packages or workspace, it will generate some errors at some times. So the errors can be logged into some specific space that is called log folder, and then there will be a folder called src, which is called source code. Basically that is the folder where your every ROS program is going to be saved, and src, and there will be a folder called install. That install folder is nothing but it will have more binary files. Binary files here means executable files. In Windows we say executables, in Linux we say binary. Okay, and install src. Hmm. And build file. Okay, So we are not going to create these four folders actually, except one. So we have to go inside our workspace like this. Oh, so here you can see cd means change directory. So right now we are in this directory. Directory is nothing but the place you are in. So you have to go inside workshop. So you have to give cd and then the specific folder, and if you click enter you will get inside this. And right now we are inside the workspace, and what we are going to do is we are going to create an src file folder. Okay, so in order to do that we know how to do it. So right now you can check whether it is created. You can actually see it is created. So how do you build an there are three folders which is actually remaining: build, install, log, right? So we are not going to build it. There is a command in ROS where you can use it to build an workspace. So what do I mean by build? Basically we all know that in order to do some sensor work or some projects like this, some robotics projects, we need more libraries, right? In order to maintain or install those libraries, we don't have to specifically mention I want to install this or that. So what we do is uh, there is a tool called Colcan. Okay, so Colcan build is an command which will help us to build the ROS2 workspace. And if I click enter, it is finished. Basically it is actually finished because it has nothing in it. So if it has something like, I can show you an example. uh, ROS2 learning, right? ROS learning. Okay, now this is my another workspace I actually created for ROS. So I can actually give Qualcomm build here, and it is showing me error. Okay, fine. It's okay. It's not working, guys. Once again. Okay, it will work, I guess. See. So if you want to get outside of the your directory, you have to give cd and nothing else. So if you give simply the cd, it will get outside of your directory. And I have to give ROS2 okay. Here you can see this output, right? So I built it and it successfully finished. So this is the time it took to build my workspace. Since it is very small, it will take around 1 or 2 seconds. If it is very big, it will take a few more seconds. So right now we actually finished the Qualcomm build in our workspace also, right? So what we can do is we can actually see, at first we only had SRC. When we did Qualcomm build, build install log also actually created. So inside this build, you can see Qualcomm ignore. So basically, you don't have to get into this build install and log as of now, because these are like an helping. It has more helping commands or something to make the Qualcomm build work actually. So I have an actually I have my own workspace for my project. I can actually run it. So these are all the commands I should follow to run the ROS completely. So I will actually use it now. So you guys will be aware of terminal, but not terminator. Terminator, because terminator is like, when we are actually using ROS, we will be using multiple commands at the same time. But in terminal it is not feasible. It is not actually user friendly to use multiple terminals, right? So in that case what we can do is uh, control shift oh no e what the fuck, control shift e. So if I give control shift e, it will give me a vertical division, and control shift o, it will give me an horizontal division. Okay. um, So since I have four commands, actually technically it has five, but four commands only. So I will explain. So The commands here will explain the core concept of ROS actually. So I will go through it once again. So can you guys see source opt ROS humble setup dot dash? So it is nothing but whenever you are opening a terminal, there is an bash file which is actually running at the same time. What it is why we use terminal, we the terminal will give a connection between us and the system, right? So in that case it should actually run some more executables backend. It will not be visible to us, but it will be running. So that is what we are going to do is, in that file, when we turn on terminal, there will be a file running, right? In that file we are going to give source and this bash file. What it will do is, it will actually source our ROS workshop to the terminal file. Why we are doing this is, let us say this is one terminal, right? So we have to access our ROS workspace in this whole terminal. We can't actually give each time this line, right? So we are going to use at one time, and it will actually be available in the one terminal forever unless we close it actually. So, and cd ROS snap is nothing but it will go inside my workspace, and then in my workspace there is actually an bash file which is inside the folder I told you, right? Install. And if I click enter, right now this terminal is actually, it will work in my workspace. Okay, I will show you now. So right now the four terminals I have to make it source, I have to source it. So I am going to copy paste it on the four terminals. Hmm. Okay, since we are actually going to use multiple Python files, right? That's what I mean when I say node. So we can't actually, in my program I will be having around 10 to 15 Python files, and I can't actually give manually give the run command for each Python file. So what I will do is, I will create a launch file. This is a launch file. How you have to actually run the launch file: ROS2 launch, and then the place where it is. Okay, the like the directory where it is. It is also in Python file, but basically including all the commands which we have to run. So if I click enter, so the things you are seeing here is like, you can see the state publisher, right? So I actually told about publisher and subscription types of communication, and it is actually doing that. It is actually publishing, and I will explain what is gazebo too. Okay. Hmm. Think நான் ஏதோ mistake பண்ணிருக்கேன். இது ரன்னே ஆக மாட்டேங்குதா? So in order to end your running terminal, you have to give control C. So control C will have you guys used OpenCV? OpenCV? No. Okay. When you actually use OpenCV, what you have to do to close the window of the output, you will click Q, right? It is a default alphabet which they use. Like that, we have to give control C, which will basically terminate all the running files. And in order to copy paste a command in a terminal, we have to use control shift V, not control V, because control V will it will be like this. It will not actually work. It will be like an it will not take it as a copy paste kind of stuff. Okay, so here I am going to run my launch file, and then here I am going to use Slam toolbox. What is Slam? Basically, Slam is simultaneously localization and mapping. Okay, I will explain it in a minute. And then ROS2 teleop. Teleop, you guys know how what is teleoperation, right? We actually control our system using an our keyboard or any joystick kind of stuff. So we are going to use this terminal as a joystick, and then this is RBIS. I will explain it once again once it runs. Hmm. Okay, can you guys see the simulation here? So right now what I did is this is my bot I designed in ROS tool. Basically what we will do when we are actually building and design, we will use Fusion 360 or else SolidWorks kind of CAD software, right? But here what we are doing is URDF file, okay, unified robot description file. So that is like, how many of you guys actually worked with HTML, web development HTML? Right? So there will be more tags and closing tags and end tags like that. And URDF file will contain more tags. I can actually show you now. Um, Source, my bot, description. So can you guys see this is an Zacro file. Basically you can't actually design your whole entire system into a single file, right? So what you are going to do is you are going to split the files like a parts of it. So this is a part of my system where you can see it is in an tag coding. It is XML format. Okay, so this is how the design of our system will look like in ROS. If you want to deploy your system in ROS, you have to use URDF file, and this is a URDF file. But you can ask me, but it is in Zacro. Basically, Zacro is like it is built on URDF. Yeah, Zacro will help us to segregate all the URDF file and combine it together, and then okay, now I will explain what is gazebo and RVS is. So how many of you guys actually worked with simulations? Have you guys worked with simulations? No. So what is simulation means? Basically replicating your practical idea or a system into a digital thing, and we can actually test rigorously in that. We can actually give various parameters to our system, like we can see how it works, right? So this is what we are doing. Gazebo is like a virtual environment thing where you can actually create an environment. You can actually create a city itself, so that you can deploy your bot into that environment, and you can see the changes in the bot actually. So okay, I mentioned that gazebo is used to create the virtual environment. Then what is ROS? I mean RVS is. RVS is nothing but, here you can see some lines, right? That lines is nothing but my camera's range. So in my system there is a camera here, and the red color thing you see here is the lidar. So yeah, what, zoom in. Yeah, one second. Okay, so here I used a differential drive system. In front the blacker thing is the caster wheels, and so ROS is used to, the camera is giving an output and the lidar is giving an output. Basically, these are sensors, right? So in order to receive the output and see the output, we are using RVIS. So in RVIS, we can actually, what is RVIS is? we can actually see the our system's sensors output actually. So that is why we are using Orbis now. And I can actually show you something. One second. So in this, I actually created an home or navigation sample environment. I will actually show you. If you click and drag it here, it will actually come. So can you guys see the small environment I created, and you can see the output of in Orbis do. So the red color lines is nothing but the lidars mapping. Okay, and in order to see the camera's output, here you can see the camera's output. Okay, uh, so this is thing, and using the teleop we can actually control our system. I will show you once again. I told that teleop will be we have to use the terminal to control our system, right? Teleoperation. You can click this terminal, the terminal which you ran the teleop command, and you can give I J K. Okay, you can you guys see the my system is moving now. So can you guys understand what is happening now? So the white color, you can ask me what is this white color thing on the surface. This is nothing but it is actually mapping at the same time. So I ran a command called slam, right? Have you guys noticed that? I told the slam is nothing but simultaneously localization and mapping. So that is what it is actually doing. When you run your system all around the environment, the whole system is mapped, and you can actually use certain files and certain commands where you can actually click here. If your bot is here, the bot will actually navigate to this place. So there are some conflicts happening, so I couldn't be able to run it as of now, but that's how slam is actually working. And you can ask me like when I click here how it is actually finding the shortest path, right? There are multiple ways it can reach this point. So for that only we are using A star algorithm. So this is the basics of ROS actually. And you have understood gazebo and Arvis, I guess, at least what it means. uh, can you guys ask me some questions so that I can actually make you guys understand very easily? Do you guys have any questions now? Even if yeah.
Is it possible? How do you simulate the behavior, whatever we want it to do? For example, let's say we create an environment where let's say this room. I want something to go from that edge to this edge,
Hmm.
and there are tables here. Nothing controlling the object.
Hmm.
Is it possible to program it via the software itself, or do we need to upload a code in that to the option?
Yeah, we actually have to code it actually, to be honest. Yeah.
And what about the controller? We have to design add the controller as well to the
Hmm.
object then upload the code.
No, it's not like that. You will be as of now we haven't used any microcontroller here. We are just using a teleop library, which will allow us to move our system using our keyboard itself, yeah, manually. But what you asked is can be done in this, but you need to make more Python files for it. And if you want your system to be autonomous, or you just want to go there and come back like that, it is a structured programming, or you are trying to do an autonomous system.
Now just go there.
Okay. Actually, you can do that. In you can actually do what, as I said, you can actually click in the map, and then your system will come to that place, right? That is actually done in similar kind of way what you are saying.
Autonomous.
So how you are asking me how to make it autonomous? In order to make it autonomous, what you will do in your Raspberry Pi stuff? You will actually code, right? You will actually code Python programs and stuff like that. Here you have to, in Raspberry Pi and all, you will be having pin numbers for your respective motors and sensors, right? Like that, you can actually include your pin motors, sensors. There, that's how you actually program. It's similar to what we do there, but you need to have some knowledge in ROS in order to achieve that actually. So that's the thing.
You have to build your real life project into this. That's
No, we can. It is not necessary to build a physical system for using this. You can actually design it in the software itself.
that's what I mean. Like,
Huh.
whatever we have in mind, we have
Hmm.
to fully do all the sensor wiring, everything has to be.
Hmm.
Only then we can properly simulate what.
Yes, 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 yes. In Fusion 360, I have heard, but I have never worked with Fusion 360. But you can actually, there is multiple options, right? While exporting an Fusion 360 file, in that there is an option called URDF. So if you click that URDF, you will get the basic URDF of your system itself, and you have to just include your sensors XML code into your URDF file, and it will actually, if you want, if you deploy it, it will actually run. So I can actually explain the deploying steps, but it will take time, more time. That's why. Okay. Yeah. Mm, so actually, we are at the end of the session, basically. So this is the output of and path planning ROS simulation. I tried it by myself, but there are errors which will, you know, stop me. It is stopping me from completing it. So have you guys know the A star algorithm, right? So A star algorithm is simply this function. So this function will say that, let us say, this is your the starting point of yourself, and this is the point which you want to, it is a goal point basically. So there are two ways. These circles represent a node. I mean, it is a node, okay. And what is this algorithm is used to, find the shortest path, and by adding an what is this heuristic thing. What is heuristic thing? Okay, let me say an analogy. So there is a cheese in the output of the maze, and there is a mouse in the starting place, okay. So the mouse, what will the mouse will do is, the smell of the cheese, it will chase behind the smell of the cheese, right? So whenever it actually has the more smell, and it will go in that side. So that's how heuristic will work. Heuristic is nothing but making guess where the our goal point is. So for example, like, this is how it works. So this is the shortest path we have now. Let us assume this is the shortest path, but this is the actual shortest path. uh, this is the displacement, right? So this is in this direction, but if we choose this direction, the angle, like, it is actually deviating, right? Instead of this, we are going this way. So this calculation is done here, and then the less the angle between the actual direction we need, the more the value it is. So this is the for a value, it will give the value of the most shortest path, and that's the A star we implemented in this simulation. As you can see, the line is going there, right? That's how this algorithm is only employed there. And so that's it, guys. If you want the GitHub repo of this project, I will share it to you. Okay, there is actually a lot of GitHub repositories for this example, but this is the one which is very latest. Otherwise there are in a ROS1 version. So do you guys have any doubts, or you want to say something here? No. Okay, thank you, guys. Next Pava will take.